Today, we're going to have a quick chat about the Pulumi tool that we wanted to look at. So we have a lot of experience with Terraform and other similar infrastructure as code automation. So we wanted to look at the actual comparison a bit of the tools, the options that it provides, if it's better for some cases, if it's worse, and so on. So first, I think we can start with a bit of an overview of what Pulumi is, how it works, and some kind of general things it has, and then we can move to some specific parts of the Pulumi tools and some comparison between the other tools as well that we use, like the Terraform and the other options. And then we can look at a quick demo of some, just spin up some services with Pulumi to see how it looks and so on. So first, in terms of introduction, so I don't know if most of you have had the chance to look at Pulumi actually. It's a infrastructure as code automation tool that is very similar to the other tools in the way it works. The main difference between the infrastructure as code tools that we already know is that it uses general purpose standard programming languages like Python, like JavaScript, TypeScript, Golang, and the I think the only other supported one is the C# language. So this is the main difference. The main benefit that they tend to advertise is that you can still use infrastructure as code, except that you don't need to learn a separate DSL language, like domain-specific language, like the HCL syntax that Terraform has. So their main selling point is that you can use your own programming language that you already use for your application to actually develop your infrastructure and maintain it in the same code base, which is the main benefit that they have towards the other tools. So this is the kind of the general overview of what Pulumi is. So I have a few things I can show you, which I took from some ready-made documentation that they have on their sites. So this diagram pretty much shows how it looks like, how it works. In general, this works very similar to Terraform and other tools. So this part at the bottom here, pretty much you can imagine something like your main.tf file where you define your resources and things. When you execute this file towards with the actual tool, with the Pulumi CLI tool, or the engine itself, what it does is just writes a state file, which state file has your current infrastructure state, details of how it's configured and all of this. And along with this, it actually executes the actual steps towards the AWS API, which creates these resources, or let's say the Azure API or the Kubernetes API, to actually provision them. So when you make a change afterwards to this infrastructure configuration file, in this case, it's a JS file because this example is for JavaScript. When you make an infrastructure change in this file and make a kind of a run with the Pulumi CLI, it would verify your state, see if there's changes. If there are changes, it will update the state and then execute the actual API commands towards the actual API calls towards the AWS or other cloud APIs. So if a change fails here, it's very similar to Terraform. So if a change fails here, it will just not provision the resources, and it will keep your state with its previous configuration. So it updates the state only after something is actually deployed in the current infrastructure. So this is the main overview of how it works, which you're probably already familiar with because it's very similar to what we already use with the other tools. So some specifics that we can see here. The way Pulumi has organized their kind of project structure, resources, and components is a bit different. So pretty much when you create a project in Pulumi, it's comprised of a few components. They are mainly a project, which is the high level structure that contains everything else. It's just a, let's say, your client name or something like this. And then you have specific granular controls, which are the stacks. So the stack here will be your environment specific configuration. So it will be your development, production, QA, and so on environment. And then the resource is, you're mostly familiar with this part. It's the actual individual resource that you create inside your cloud provider or Kubernetes or whatever it is. So resource is identical to what we have in Terraform. As far as I understand it, at least, I haven't seen any major differences when I looked at this. So I think it's very similar. It works with inputs and outputs in the same exact way as Terraform does. Like inputs are standard variable inputs, and outputs are stuff that is usually known after you provision a resource, like your ARN, yeah, like your DNS host name and stuff like this. So these are the main components that we have in Pulumi. As far as I understood, I didn't see any other major components that are relevant at this stage. So I think these are all of them. And after this, I think we can look at the actual, I think we already looked at this, but the languages that Pulumi supports are these four main languages. I think they're working currently on integrating a lot more, but these four are currently the supported ones with the most resources and examples that we can use, and an actual standard library in each of these languages that we can use for infrastructure automation. And so for Node.js, I think they support every single language that is compatible with Node.js, and especially the most resources I found were for TypeScript and the most examples and everything. So it's probably the best language to use this with at this stage, at least, because it has the most resources. But as far as I saw, the actual library and functionality of each of these languages pretty much supports everything you need. It's just that you don't really have too much documentation, too many examples, and you usually have to go through like the API references to find what you need to do and how to do it exactly, which is makes it a bit difficult, but still it's usable. So these were the languages. Let me see if I can find the link for their GitHub, because they had a better overview of languages there. Just one sec. So yeah, this is their GitHub. This is where they maintain their actual application and libraries and everything. The Pulumi itself is entirely open source, like you probably guessed. It's very similar to Terraform. There's a bunch of examples here, a bunch of links to documentations, the introduction videos of how it works and stuff like this. Some CLI tools that we'll go over a bit later. The actual general list of languages supported, their versions and everything. And pretty much we can see here each specific language's configuration, runtimes, libraries, and everything if needed. We usually don't need this too much. We can go through their documentation to find the individual API references and things. So next, I think we can look at the API reference. So there's I think probably what's good is to actually see what they support. So when I went through this stuff, I think they actually have a quite extensive amount of providers, provisioners, Kubernetes operator, monitoring components, networking components. So they have quite a bit of things. They also have kind of utility resources like Terraform does for random resources. I think it's still lacking definitely compared to Terraform, because it's Terraform has been kind of on the market for a very long time, and it has a lot of options. But still, it has quite a few things, and I actually expected it to have much less, especially with obscure providers and things like this for the single sign-on and all kinds of other things. I haven't gone into too much detail in any of these. So the main focus that I took was AWS. So we have something that most people will be familiar with especially in comparison with Terraform. So this is what we will look at, but still it's good to know that they support a whole bunch of things. And if needed, we can use most likely a lot of these. For AWS specifically, uh, most APIs actually look like this. So when you go to the actual provider, you have kind of a general list of all the resources that can be managed by Pulumi, which is again similar to Terraform, and some other additional logic that helps you do some stuff like, for example, look up AMIs and things for the case of EC2, which is similar to how you do things in Terraform with data user data logic and stuff like this. So the way we would use this reference usually is any of these resources. When we go to each resource, it has a whole bunch of components it can manage, and each individual component will have an API reference and language specific references. So there's a lot of differences between the different languages, usually not only in the syntax but in the actual parameters you would use. So they have separate documentations. What I found is that the most documentation, like I said before, is for the JavaScript and TypeScript based automations. Probably this is what they started with. So I found a lot of stuff to be lacking in Go, which is what I used for most of my tests, and most of the examples I'll show you a bit later. So I found a lot of things to be lacking in terms of documentation for Go specifically. We see a lot of parts where it's coming soon, so I guess they will probably update this and put it at some point in the future. But for now, we have to kind of go through the actual API and figure out what we need ourselves, instead of just seeing an example of how to do it, which is a bit harder. But yeah. So next, I think we can look at the actual. So yeah, so like Terraform and like the other tools, the way we execute the actual logic of what we automate is with the CLI tool in most cases. So the CLI tool is very similar. It has most of the functionality we already are familiar with some additions. So for example, the projects and stacks and things that I showed you before are created with pretty much you create a project with this command line option, and then after this you can just create separate stacks. Once you execute this part, it actually just generates for you a set of like configuration files that define your actual project structure. These are just like metadata config files. And the same for environment level specific configuration, as far as I understood. For the most part, I haven't actually made any changes to these files manually. Rather, when you need to add something or to change something, you would execute a CLI command, which would update this metadata file. And then when you run Pulumi commands, you run them in this context, in this specific directory, and it just uses these configs to see where you are, what to do, and to which environment to actually deploy your stuff. So yeah, one thing that I found to be really useful is that there's a config level. There's a config tool in the CLI which you can use to actually configure specific local environment variables. Like you can actually configure even secrets that are encrypted in the Pulumi tool itself, so you don't need to add additional abstractions like you need to do in Terraform to, for example, store an encrypted value somewhere and then use it. You can actually use the Pulumi itself to store configs locally, and you can even store encrypted values. And along with this, you can even, I think we will see this a bit later, but we can even see, or we can actually even use the Pulumi CLI tool with an extension for external secrets management tools. For example, I can encrypt a local secret in my Terraform state using a KMS key without needing any resources. I can just use the Pulumi CLI, make a reference to the KMS key, just have enough permissions with your user in AWS, and just encrypt your local thing in using KMS. You can do the same with HashiCorp Vault and other similar tools like this. So yeah, this is the CLI. We'll see it a bit later how to actually use it. There's a lot of stuff that I haven't really used most of this stuff. Just the main things this the import tool I actually found very useful, but let's just push this for a bit later because I have an example that I can show you. So this is the general overview of the tool itself, of how it works and how it looks. So I think I didn't show you this, but this is their guidelines on the actual project structure. And of these files that I just told you about, the metadata files, which just contain usually a project name, a runtime, which defines, for example, if you use what language you use, because it entirely depends on which runtime to use for, sorry, not this file, because it entirely depends on which runtime to use to execute your logic towards the AWS APIs and the other APIs. So in my case, I think this should be a Golang runtime. Yeah, so it's just a project name, a runtime, a description, and I think it can have a bunch of other configurations as well, which are optional as far as I understood. Yeah, one thing that actually I found which could be very useful is Pulumi has also a number of abstractions which they call crosswalk, which is some sort of an additional easier to use production ready abstraction where you don't need to really write the whole logic of something that is very standard, for example, like a Kubernetes cluster in AWS, or for example, a very common AWS set of resources. So what they've done is they've actually developed a set of abstractions which you can use to just spin up a set of resources very easily. There was a good example for Kubernetes where instead of having to define every single resource you need for your Kubernetes cluster, we could use this additional library, which is the AWS X option, with the X pretty much makes it this crosswalk abstraction, where you just kind of use a resource which creates a cluster. You just set your cluster name, number of nodes, configuration like this, and then define your YAML manifest on top. So you just create a cluster and deploy a resource on top of it with something like 20 lines of definition, which in Terraform you would need to define your whole Terraform module, additional resources like VPCs, security groups, subnets, all of this stuff. Then use an additional provider to deploy on top of it. So I think this could be one of the more useful cases where if you have a very standard case like spin up a Kubernetes cluster, deploy something simple on top of it. This probably will be much more useful than having to define everything from scratch in Terraform.
Is it to some extent similar to Terraform modules, or?
It is, except that it's a grouping of something like a grouping of modules with an additional logic of how they group together, and you would just have to modify the variable part. So you would just modify the actual size, your names of components, and just spin it up without having to do each individual module separately. So yeah, the last part of the overview I want to show you is, so one major difference between Pulumi and Terraform is that by default, it does not keep its actual state file locally. So Terraform, when you run something with Terraform, it creates a state file which is kept locally unless you use a remote state configuration to store it in something like S3. The difference here with Pulumi is that it does not by default ever store the state locally. It stores the state in their cloud service. So you create a cloud account in their Pulumi dashboard, and then you use an API key in your Pulumi CLI tool to connect to your cloud with your user that you created. And then from there, whatever resource or project you create, it just appears here. Shows you the name, the description, the environment. This will show you the list of stacks that you create and the language runtime in which it was created. So this is a bit of a difference, but still, as I saw, Pulumi supports entirely using remote states, so we can even store the state somewhere else. And in fact, as far as I saw, it also supports actually taking resources from other states. So for example, we can manage resources in a Terraform state from Pulumi. Their idea with this is that they're pretty much aware that you would not really, if you want to switch to Pulumi, you would not really develop your infrastructure from scratch. You would rather do a more gradual approach where you do service by service, and you can use these abstractions to actually make references to the current Terraform state and just use the existing resources until you migrate them all to Pulumi. And yeah, so this dashboard, like I said, contains your project specifics. And if you go to any project, you see a set of configurations like these. So you see the configuration level variables on Pulumi level. You see some secrets if any exist. You see some other tags and things. In the actual activity tab, you see a kind of a pipeline level, pipeline-like execution of your runs. So when I execute my Pulumi command line update, or when I execute some sort of an automation that I developed, it appears immediately here, and you can even see it live as it executes. You can pretty much see everything that happens. It shows you the resources you're deleting, updating. It shows you what exactly is going to happen. It shows you output parameters and all of these things. And you even have a kind of a version history of what was executed at which point, which is good, and which is something that I don't think we have in Terraform. Maybe it's actually available in the Terraform cloud, but I personally haven't used it in too many cases, so I'm not sure. And yeah, the rest is fairly standard. Here we will actually be able to see a list of services that we've created with names and everything. And there's even a graph view which shows you the references of, let's say, a specific environment and the subset of resources that you've created for this environment and the way they kind of depend on each other. I think I'm not sure about the dependencies and things, because I haven't created any too complex set of resources that depend on each other, but I think the idea is this for this tool. Yeah, so these were the main overview components I wanted to show you. Next, I think we can look at a few things. So first will be the actual comparison of why exactly do we need to, let's say, for example, if Pulumi is just a infrastructure as code using a programming language, why would we not just use the actual cloud SDK, like, for example, the Boto 3 or the Golang SDK library or something like this? And the reason for this is that, of course, we can use directly the cloud SDKs, but there's a lot of abstraction and a lot of logic that we would need to develop from scratch. So, for example, the main points that they mentioned here are that when you use an actual infrastructure as code library instead of directly the SDK, you don't need to think of actual state management. You don't need to think of concurrency, and you don't need to think of how to visualize your diff changes. For example, to visualize what is your previous state, your current state, your future state. All of this stuff we will need to develop from scratch if we use the actual cloud SDK and these abstractions that the actual Pulumi library actually implements. So these are the main benefits that that we would have to using this instead of directly the actual SDK. So these I think are the main selling point for them, but in general, yeah, it's exactly just a library that you import in your language, and you just use it with a set of instructions that they've or set of abstractions that they've actually made for you, so you don't need to think of them too much. And yeah, so the next thing I think we can look at is a bit of a comparison between Pulumi and Terraform, especially for the case that Terraform is probably the most popular alternative to it. So there's a number of differences. I think I mentioned a bunch of them before, but still we can go through some of them in a bit more detail. I think first is the syntax. So like I said before, Terraform uses a kind of HCL language that they call it, which is a domain-specific language, which you need to learn explicitly for the purposes of using Terraform. which is good for like infrastructure people and DevOps people, but it's not too good for developers because they need to use a entirely separate set of tools and languages to just maintain this. And the main benefit of using Pulumi is to actually use your same language that you develop your application in and just develop your infrastructure in the same exact thing. So how things look like in comparison is pretty much they're very similar. So for example, in Terraform, when you create an EC2 instance, we usually just, for example, you need to look up on AMI of the image you need to use. This is done with these filters, and we do the same exact things in Pulumi. You can just ignore the first parts there, just language like fluff and stuff. This is the main filtering part. So it's very similar. You just use a kind of a library and a specific function call that just makes a AWS SDK API and just does the same exact thing that you get here. And then afterwards, when you need to use the actual, when you need to spin up an instance and use the actual AMI, which you've taken previously, this is where the programming language is significantly better because you don't need to use these kind of non-standard data sources and things. You just directly make a reference to the object of what is returned. So for example, when you just spin up the instance, you can just directly use your Ubuntu variable and the actual specific field of what you've retrieved in this request directly, which makes it much easier to manage and to actually just use instead of having to define some more complex things that are very hard to understand, especially for people that are not familiar with the syntax of this. And yeah, so one thing that is a bit that I was not expecting is that, by default, Terraform uses a declarative sort of language to declare your infrastructure state. And Pulumi actually also uses a declarative approach, which is something that I was not expecting because it's a programming language, and as a programming language, it's more imperative rather than declarative usually. But still, what you define is kind of a declaration of your state of how it will look like at the end. So you use the imperative parts of your language, like functions, calls, and all the other things that your application, your programming language has, like interfaces and functions and classes and all of this additional complexity. But at the end, you just still define a declarative state of your infrastructure. And so next is one thing that I found is at this stage, at least, Pulumi tends to still be in its earlier stages of development. So while I was doing some tests, I actually found a lot of API changes. For example, there's a bunch of examples from a few months ago that show a API reference that is no longer correct. So I feel like they still tend to make a lot of breaking changes in their APIs. So I'm not sure to what extent it's production stable at this point. For example, I was looking at references to this specific resource previously. It seems to have been called lookup AMI, and they switched it to get AMI. And a lot of the examples they have are with the lookup command, which does not really work in the same exact way as their API references pretty much show it. So I think they still need some catching up with this stuff, but probably in the future this is going to be a bit better. And yeah, keep in mind, my tests I did were in Go, so I'm not exactly sure if it's the same for Python or for TypeScript. There it might be a bit more stable. But yeah, that's just the experience I got from the impression I got from these tests. And yeah, actually, I can show you maybe this in Python. You probably are a bit more familiar with this. It looks a bit more simple, but at the end, you just execute like a function call from the library, makes an SDK call, returns your specific resource as a variable, and then you just use it. One of the other good things that is a bit better in Pulumi than it is in Terraform is that because it's actually full-fledged programming language, we can use a lot of things that we don't have in Terraform. So you probably know if you had to do some complex cases of Terraform where you need a lot of conditional logic. For example, you have a database module, but then you cannot use the same exact module everywhere. You have a application that uses 2 or 3 databases. You have an application that requires a specific setting. Then you have another thing, and you have to make a module and then make a bunch of workarounds with count variables and for each loops and all kinds of other things to achieve these things in a declarative language. This stuff is significantly easier to be done in a programming language because you have all the functionality of just putting your conditional logic any way you want it. One drawback actually of this is that because you have this control, you also have the problem of each individual developer and DevOps person can actually create its own logic for how to manage resources, and it's much harder to standardize because you have to enforce your standards by making sure your developers use the same exact approaches. Whereas in Terraform, even if you use workarounds, in most cases, people that know Terraform will be able to understand it fairly easily. Whereas here, you have the freedom to pretty much develop anything like you would in any application, which gives a bit more potential problems for management, but a lot more control for you. Yeah, so one place where Pulumi actually falls short compared to Terraform is structuring projects. So one major benefit of Terraform here is that the modularity and all of this stuff where you can create a separate module for each component. For example, I can show you in Terraform, you can usually just create a set of modules individually, then a set of environments, and then make references to your modules as each individual environment, and then even separate your specific variables and parameters into a separate configuration, making one large code base that can be used for a lot of things. And then you can even use additional code bases that fetch from your first modules and all of these things. The problem here with Pulumi is that it does not really have any integrated module management that is this easy to use. The main way you would achieve modules in Pulumi will be to actually use the programming language and actually develop the logic of your modules yourself. So, for example, you would make like a set of files which you import as like standard libraries in your language, and then you just call your functions of what you've developed as a module. But as you can probably understand, where the problem with this is that you would require a lot more effort to actually develop your module structure and make it, and it's completely in your control to make it as reusable as possible. Whereas in Terraform, this is mostly out of the box. So I think this is where Terraform is much better. And actually in the official documentation of Pulumi, they kind of advertise their tool more for large monolithic code bases and for kind of micro projects. It's where it will be a better fit. Or if you have a very specific case, which the benefits of using better conditional logic is more strong, so you can use actually Pulumi for this. But if you have a large project where you need to have a lot of resources, a lot of modules, and a lot of things like this, I would personally pick Terraform for this case, definitely. And we can actually move on to the next parts, which are so I put a bunch of topics that I found interesting in Pulumi, and I can show you a few of them. So I just made a bunch of notes with examples and things that we can go over. So first is state management in Pulumi. for this stuff, so for the state management, like I said before, state is stored in this cloud Pulumi cloud tool, and if you don't want this, you can store the state in S3 or anything else. One thing that I found very nice is to actually debug issues with states. It seems to be a little bit better from what I saw so far. It might be with more complex states that it's not, but what I saw is, for example, I was testing with a set of resources, and by accident I actually deleted one of the resources, and then on any run of Pulumi afterwards, it was failing that it's trying to delete a resource, but it doesn't find it, which is something that also happens sometimes in Terraform. So you would need to kind of recover your state somehow. And there's a few things that I found very useful. One is the Pulumi refresh command, which just refreshes your state. And what it does is it compares your state towards the existing AWS infrastructure. And actually, if something is missing there, it is missing in the state, but actually exists in your infrastructure, it just updates your state and adds it there automatically, which is very useful for this specific case. One other thing that was very nice was the ability to actually import existing resources. And the way this works is similarly to what I mentioned here, but there's one problem usually with this. So when you try to import a resource in the state, you can import it in the state, but then this resource does not exist in your code base at all. So what Pulumi does is when you import a resource, it both imports it in your state and actually generates your source code in the language of your runtime of what you need to manage this resource in exactly the same way as it exists. So it takes every single part of your resource. For example, if let's say this is an S3 bucket, if the S3 bucket has an ACL policy, it will just take the whole configuration of exactly how you have it and just define your resource, so you don't need to think of this, which is very nice. And I actually tested this with one resource that didn't exist, and it really works very well. It just imports it in the state, generates your code. You take your code from here, put it in your existing code base somewhere, and then the next run that you do, it just will not see it as a separate resource. It will just completely work like it was created from scratch with Pulumi, which is very nice. And so next, testing is one topic that I think is good to see also. So you probably know that when you use infrastructure as code, usually testing is something that falls behind in terms of development. So there's usually not out-of-the-box tools and things that you can use in Terraform and other tools to actually do proper testing of your infrastructure. There's like outside tools like I think Terratest and similar tools, but they are separate. And one major benefit of using a kind of a full-fledged standard programming language is that you can actually just use this language to test it like you would any program. So unit testing especially can be done entirely in the language. You don't even need a Pulumi specific thing at all. You just use your language's testing framework and just test your resources like you would any other function in any programming language. So I'm not sure if everyone knows unit tests, if what they are and how they are used. In general, unit test will be to take each individual small component of your application. For example, if a function that you execute takes the proper input and returns the proper output, this would be a unit test. And this could be automated very easily in your programming language if you're already familiar with your testing framework, which makes it much better and much easier to actually automate all of this stuff in a pipeline. And then when you run your infrastructure automation, you will make sure that you don't introduce breaking changes, or maybe not make sure, but at least it will help you reduce the potential for this. And other than unit testing, there's also a Pulumi option for integration testing, which is where the more complex parts of infrastructure as code come, because to actually test your infrastructure, you need to actually spin it up somewhere. So the actual Pulumi library for integration testing will help you pretty much do this. And the way it works is you can define a set of tests for your infrastructure based on the components that you use and components that you have defined. And then using this library, we can actually spin up an ephemeral environment, which is temporary, runs for just a little bit. You execute, make sure that it executes, that it creates your resources. And then even on top of this, we can put some logic, like for example, some application calls or some health check calls to verify that stuff actually works. And in this way, we can spin up the whole infrastructure in a pipeline, verify that it works, tear it down, and then only then execute your actual production deploy. One of the places where this could be a bit difficult is, for example, if you manage a complex stack of resources, for example, in an automation like this, I create, for example, a VPC, a subnet, and other things in Pulumi, which is probably not optimal to test in your production account, because if you break something, you could make major changes to your VPC or subnets, which is a significant risk. So I think what would be the best approach for using integration testing would be in a separate account, which is usually not really, not always doable, because it's additional cost. It's a separate set of resources, a separate set of places to manage. But I think this will be the perfect case of if you have a serious application for production that you maintain, it probably is a good idea to make a set of unit tests and then a set of integration tests and execute them on every single pipeline run on a separate AWS account to make sure that things actually work like we expect them. Yeah, so this was for the testing. Next is the organization and project structure. I think we already went through this stuff. I don't really need to go in detail. Like I said, there's three components: project, stacks, and resources. These are the standard files generated when you create a project that define the logic. So input and output parameters. You know, probably in other languages for infrastructure as code, input parameters are fairly standard. You just define a resource, then you put input parameters which are variables, or you make a set of resources. One takes the output of another as an input. This is fairly standard. Where Terraform is a bit difficult is usually with managing output parameters, especially in the cases where you have complex conditional logic again. So for example, if you have a set of resources that you maintain a different way, or if you have resources that you have that you manage with count variables, in the case where you enable or disable them, managing output parameters is not always easy, because you have to keep in mind which specific count of your instance you use the output from, which is much harder. And again, since Pulumi uses a standard programming language, an output is just a deferred function call. So in a programming language, when you make I don't know to what extent you're familiar with deferring, but in general, deferring is when you execute a function, and what is deferred pretty much happens after the function call completes. So for example, let's say we create a resource in AWS, but you don't know the actual host name of this resource until it's created. So the actual response of what is your host name is a deferred pretty much the callback that you can do to retrieve this value after it's already created. So the way this is done in Pulumi is using this functionality, which is apply string and all. It's just a name that they've selected, but in general, what this says is to assign a URL, I need to wait for this resource to be created, and this resource, this function call will be deferred after everything else is executed. So it will actually take the name after the resource already completes. So Pulumi with this logic pretty much says, execute this towards the SDK, but wait for the actual SDK to reply with the actual resource that is created after you just provided to the specific variable, which is a bit different. And yeah, like I said, this is much easily managed in Pulumi because it's a standard programming language and you can just use this parameter very easily, even if it's a complicated conditional logic of what you manage. And yeah, actually one good case where we have where we actually use the output parameters for a very common case is this. So for example, we can actually output the kubeconfig file that is generated by the Kubernetes resource as a something like this. So it's created as an output parameter, and we can reference it within the actual application infrastructure code, or we can even reference it afterwards. So in the case of the kubeconfig, we usually do need it after to get your local kubectl configuration to join your cluster. So we can just use the Pulumi CLI, take the output parameter that was generated by this function call, and then just output it to a file, which we then use for our kubectl. Okay, so secrets management. One thing that is that I can show you is a few examples of how we actually manage things. So, for example, what is good in Pulumi is that no matter what you do with your state or whatever resources you create, they are always transmitted with SSL encryption, and they are also stored with default encryption when using the dashboard and things, and also whatever place you use as well, it pretty much uses the same kind of logic for this. Except that when you put the state in something like S3, I think you cannot really, the state itself is not really encrypted. You can still see the values inside it. So it gives you the option to actually, Pulumi gives you the option to actually encrypt individual specific values within the state. So even when you open the state, you still don't see a something like a database password. We can pretty much use a few different approaches. Like I said before, it supports both library level components and actual external services and providers to encrypt things. First, I think this example is a configuration where we actually store a specific value in a parameter store in the AWS. So we can actually use this similarly to what we usually use in Terraform, which is, for example, if you create a dynamic database password and you don't want to show it or save it anywhere during the pipeline or the Pulumi run, you can define a resource where after this password is generated randomly, it's directly stored in parameter store, and then in your next resources, you fetch it directly from the parameter store using just the key instead of the plain text value, which provides a lot more security. So not put any plain text configuration in your code or your pipeline. And so yeah, the next example I wanted to show is so this is an example of how we actually encrypt a variable using a KMS key. So here we use the actual Pulumi CLI, which already has an integration to KMS. We provide an AWS access key to the profile where we actually execute this stuff, so it has permissions. And what you do is you just configure a provider, which is the KMS key that already exists in AWS. Afterwards, whatever value you set as secret will be encrypted using this KMS key, which is great. And we can actually use stuff like HashiCorp Vault and other providers to both encrypt and store these values and then reference them from Pulumi using this automation. And next, log handling. So there's not too much stuff about this. Just to mention, the standard library of Pulumi actually has kind of logging logic with different log levels. So we don't need to implement a separate library for just logging. We can just use this, and we can just even set up different log levels for the different infrastructure creation components, if some are critical, if some are not, to make it a bit more manageable. Also to put as much logging details as we want, which is something we cannot do in Terraform. So this is much better to make a proper logging and debugging information in your infrastructure as code, and we can then afterwards even integrate this with some external log aggregation tools to make it even usable and have history and all of these things. So for pipelines, yeah, again, not too many things we can show here. As far as I see, Pulumi has a lot of already made things. So it has a lot of examples of how to do pipeline automations in the different most popular tools. For example, if I open GitLab, we will see a sample configuration and a sample pipeline of how to make your automation in a pipeline. As far as I see, they've developed a set of scripts that will manage most of the logic. So there's a shell script that installs your Pulumi, a shell script that does your equivalent to Terraform plan, a shell script that does your deploy. I don't know if they will keep this with shell scripts in the future, or if they will make it a bit more robust. But for now, this is what it is. And in the shell scripts is just the standard paths of how to install all the things you need in the pipeline to actually run your Pulumi. And yeah, I put an example here of how we can actually spin up a so-called ephemeral environment to just spin up something, verify that it works in a pipeline, then delete it. So we just define a stack that is a temporary environment. We can generate a temporary environment with some random name, so it doesn't conflict with anything. We can spin up a set of resources that we've defined before. Then we can use something like the output parameter of a resource, let's say an EC2 instance that has a application with a health check. We can just pass this to curl, or put some logic for this to wait until something is available. Once it validates that it works, we can just execute a destroy and then remove of this temporary stack. In these 5 steps, we will just spin up and tear down a temporary ephemeral environment in a pipeline that we want. And yeah, so next is the example I wanted to show you. So I've created I want to show you how to spin up some resources that I've defined. It would be pretty quick execution because I've created just a few small resources. So like I said, first we need to create a profile in the dashboard, which I already have. Next, we need to create a project, which I will show you a bit in a second. We need an AWS account. I've created a temporary AWS access key in a test account that we can just use for these test purposes. So first, in this account, we go to projects. We create a new project. If we don't have one already, we pick the runtime that we want to use. In this case, I will use the Golang runtime because this is what I've used for tests. When we create it, we just put a name for the project. We put a description. We define the first stack, which is the first environment. We can make it like development, staging, whatever it is. Since it's an AWS project, from the options that I selected, it gives you directly the option to select which region. I can use the central region because this is where I want to test some of my resources. Once you create the project, it directly gives you the steps of how to install Pulumi in the different OSs. This is a script that works very well, to be honest. You just run it. It works for both updating Pulumi and installing it from scratch. Just create a project directory, which we can do now. I can just create one. We will not use it because I already have some automations that I've made, but I'll just show you how to create it. Just create a test directory. Go in the directory that we've created, run Pulumi new, and the actual AWS template. This is something that they already have defined. This creates a dummy or example structure for your project that is based on AWS. And if we go in our main config, It just has a sample resource that is in the context of AWS. In this case, it's just creating an S3 bucket in AWS. So this is what it creates a set of directories, and then when you start developing your infrastructure as code, you develop it inside this project directory. It can either be in this single main file, or it can be in directories, and then we go back to the problem of having to develop your own modularity in the actual application. And yeah, so once we create this stuff, we can, it creates a sample resource, so I can even do Pulumi up, which is the equivalent of Terraform apply. So what this does is it will show us now first the plan of what it wants to do. So it gives us actually a URL that is in this dashboard, where we can actually see the same exact stuff that we see in command line. So this is useful for, I think I didn't copy it properly. This is useful, for example, if you run Terraform, not Terraform, Pulumi in a pipeline, then you don't really always need to look at the pipeline itself. You can even look at your dashboard to see of what is being executed. It shows you the changes that it will make, the specific configuration, environment variables, and all of this. And so it says now that we will create an S3 bucket. It says one resource will be changed. There's no output parameters at this stage that I can see. And we have the option to either execute it, to ignore it, or to see details. The details are pretty much what we see in a Terraform plan usually. So the exact details of what will be added, what will be removed, and what will be changed. And if I just go to yes and just run it, then if I open my live view here, we can even see in the activity if it works or if it fails. I'm getting access denied. Actually, I think I didn't copy my access keys. Just 1 sec. Just run it again. And yep, now it's creating the resources, and I think we can even see it now in the activity that it's running. Actually, it completed it too quickly, so it's already done, but we can see here pretty much with when it's in running state as well. So this is the simplest form of what we create. When we create a project, we just spin up a resource. We can even change the configuration afterwards if you want to with the config part, or even directly just changing the YAML file. I think it doesn't make a difference. And then we can even use this option to see the different stacks that we have. So the different environments, we have different temporary URLs for each environment. And we can even describe the details of each environment and see what's in each of them. So the last part I wanted to show you on this demo is the set of resources that I've defined previously just for this test. So I can show you a few things that I've created. So this is in Go, like I said. So first I created a VPC. Oops, sorry. I created a VPC first, which is this part. Then I created a subnet, which is inside this VPC. It's this range, which is within the same VPC, but just a smaller range. Then I look up the AMI like we saw before. Which is done with just the library and just using the standard Linux, Amazon Linux-based AMI. Then I create a security group for my instance, which is with a port 80 opened everywhere. Just define ingress rules, and then just an SSH port open just for me. And then at the end, I spin up the actual EC2 instance, which uses all of the previous parts. So here we have the actual AMI that is taken from the previous lookup, which is this part, just takes the ID. Then we create the instance with some small instance type. We make a reference to the security group that we've created in the previous steps, which is this part. Just take the ID, then associate it with a specific IP address publicly if we want to. This is not mandatory. Specific subnet and all of this stuff, and then we can even add a map of tags if we want to at the end. And here's some syntax that I didn't show you before. They have the option to actually export some values as output parameters if needed. So the purpose of this is to actually use it afterwards in the CLI or to see it in the dashboard. So I put two parameters to output. One is the IP, one is the host name. So now I should be in the same directory, and I can actually run this logic now. Hopefully it doesn't break like it usually happens when you make a demo. So we just run the Pulumi app. It should show all of the resources it's gonna create. Actually, it shows two resources that have not been changed. Maybe I have not deleted my VPC from the previous run, so I think it probably already exists. But it says here it will create a subnet within the VPC. It will create a security group. It will create an instance, and then it will output the host name and the IP address of the new instances. It currently shows the current ones because I already created them before, and it says the new ones will be known afterwards. So we can just run this, see if it fails. It's possible that there's some conflict with if I actually deleted the VPC manually. So let's see if it fails or if it works. Yeah, so this actually finished. It didn't fail, which is good. So if I run Terraform, if I run Pulumi up again, we should see no further changes. So we should see the same exact state. Yeah, so it says five things are unchanged. And this should have created now everything. And we can even see our new values for the output parameters. So if I open now the same project in my dashboard, yeah, so here we actually see the output parameters because I exported them in the actual code. So this is something that's useful when you need to see something later. We can just export it in the code, and then in your dashboard you actually can see the exported parameters. We see configurations, we see secrets and other config level stuff. That's not too important. We see the activity of what was ran before. We even see, because it's a Git repository that I store this in, which is my personal test Git repository in GitHub. It actually detects this and it shows you the commit IDs, the branches and things, and we can even open it directly in the GitHub site. And so if we go now to the actual resources, we can see all the resources that it created and that it manages, the VPC subnet security group instance. If we go to any of them, we can even see all of the stuff that is part of the state, which is also very useful because you can see a lot of resources in the same place without having to track them down. And also the graph view that I told you about. So this shows you the stack, meaning the state, the stack meaning the environment, and then the specific individual resources that it manages. We can even, I think, click on one of them and just see the configuration again for it. And then, yeah, that's mostly it. So now the next thing I can show you probably is the Terraform or the Pulumi destroy, which should go in and try to destroy all of these 5 resources, which will also take some time. So I'll just leave it running. And I think the last part is Kubernetes. I think I can show you just a simple example of how it looks like. So like we said before, when you define something using the Kubernetes operator that's configured in Kubernetes, pretty much you define a deployment and then you define the whole kind of manifest components like replicas, templates, container images, and all these parts in the definition. And then you just execute this with Pulumi app, and this will deploy by making a actual API call towards the Kubernetes operator that runs inside your cluster. So we need to configure a Kubernetes operator, which I think is this guy, inside, or maybe this is not it. We need to actually configure the operator inside Kubernetes. We need to deploy it, which is deployed with a standard configuration that they give us. So you would go into the actual Kubernetes provider. In their documentation, there are steps to actually deploy the operator inside your Kubernetes cluster. And then when you connect, you define a project that is a Kubernetes project. You would put your configuration so that your kubectl can connect to your specific cluster. And then via kubectl, this will make this will spin up resources and things like this. And I think it can also actually use directly endpoints for making API calls, but we haven't tested this part. Good, so I think this failed, which is good. So for some reason I cannot delete my VPC, but I don't think that's too important. So the idea is that it deleted most of the resources. And if I run Pulumi up now, it should try to create everything except the VPC because it failed to delete. Maybe that's why I wasn't creating it before, because it also failed. Maybe there's some resources still left over that I created manually that probably use it. That's it. Okay. Thanks, guys, then for everything. And
thank you,
yeah,
Boris.
good.
This was very useful.